The directions in this problem say this. Use the integral test to determine whether the series is convergent or divergent. On the test you take tomorrow night, I am not going to tell you use the integral test. You have to look at the problem and figure out what test you're going to use. Personally, I would not use the integral test on this one. I can use one of the comparison tests. Compare it to what? 1 over n. If you don't mind, I'm going to work this one with the comparison test, or one of the comparison tests, because it's going to be much more efficient. So I'm looking at number 7. The integral test is the furthest thing from my mind when I see this problem. So I'm looking at the numerator, the degree is 1. The denominator, the degree is 2. So let's try this. Try the comparison test. One of the comparison tests, I don't know which one yet. With series, n starts at 1 and goes to infinity, of n over n squared. And what does n over n squared reduce to? 1 over n, which does what? Diverges. I already know this problem number 7 diverges. Okay, but I need to show the work. I need to give the rock solid argument. And if you use the first comparison test, you would need a certain inequality to hold. And let me think in my head a minute whether or not I think that inequality is holding. This is just not a formal argument. This is just my thinking. I'm seeing this numerator into the first, that's going to infinity. N squared plus 1 is going to infinity. Now, this is diverging. What about that plus 1 in that denominator? I think that's going to make this fraction smaller than this one. I did not give the formal argument, but this is my thinking. I think this fraction, term for term, is going to be smaller than 1 over n. I don't have that inequality that I would like, so I'm going to do the limit comparison test. So solution, try the limit comparison test. And the limit comparison test tells me I'm going to take a limit of, here I'm going to call this one a sub n. For the limit comparison test, this would be the b sub n. So a sub n is n over n squared plus 1. B sub n is 1 over n. And the limit comparison test, we're going to find this limit. The limit as n approaches infinity of a sub n over b sub n. So that's the limit as n approaches infinity of n over n squared plus 1 times n over 1. Now this, I skipped a few steps. I learned this from my 1552 students in previous semesters. That, you know what, okay, it's going to be this fraction divided by this one, and I'm just going to flip it and multiply and flip the second one. So this is the limit as n approaches infinity of n squared over n squared plus 1, and that limit equals 1. How do you know? The degrees. You have degree 2 in the top, degree 2 in the bottom. It is leading coefficient over leading coefficient, 1 over 1. And the limit comparison test says if you get a number and that number is greater than 0, then both series do the same thing. And I know that the harmonic series diverges, so then I know that number 7 diverges. Yes?
Is that greater than 0, so if there's a negative number that would apply?
You know what? There's something else in this limit comparison test. It says it's positive terms. So it won't be, thank you for that question. So, but at any rate, by the limit comparison test, this series, as n goes from 1 to infinity, and if you just say the series, I'll know which one you're talking about. This series diverges. I wrote it out. Somebody said this yesterday. So when you're given a problem, a series, determine if it converges or diverges and tell us how you know that. What test supports that? And show up some work to show how you know that test supports that answer.